So in this video, I'm going to be going through how to do the development from the 2014 HSC question 23D. The first thing I'm going to notice is that in elevation, all of the heights for every length that we're going to be finding are all the same. So I just did another drawing where that wasn't the case. Saying if you can get me that, I'll just to make a comparison while I'm drawing this up. But that, although I think this is a relatively complicated question, so in this case here, all of the heights are different, right? And that many of the heights are different. So only two of them have those two are the same height and those two are the same height. But it just makes the question more difficult when that's the case. The heights for all of these are going to be the same. So I've just drawn two parallel lines. That's going to be my heights. I'm going to measure my distances from this vertical line I've just drawn. Okay, the next thing I'm going to do is I'm going to go through this and I'm going to just identify which of these lines are true lengths in A view. So if we look at AB, AB is, where is AB? AB is this dot, represented by a dot there. And so it's represented as this top line here. Sometimes, I wouldn't say that you should necessarily do this in an exam, but you might. Looks like AB is the shorter of the two, AB is on the bottom. Okay, so it looks like we're drawing something like, yeah, AB is on top, and then something like that is sort of the shape that we're going to be making, and then it comes back around. Something like that is what we're going to be doing. So AB is on the bottom, C, and then D. And then we have 1, 2, 3, and 4. I wouldn't necessarily do that in an exam, but if you're struggling, you're not sure what to do, that is not an unreasonable thing to get started. Okay, so AB, which is this line it's a dot shown here, it is that line, AB is true. AB is true. I will put an underline just to show which ones are true. The 1, 2, which is also shown as a dot, is also a true length, right? So we know that true lengths are shown as dots in the other views. Here we have BC. So BC is this on the bottom. BC is true in both views. Okay, 2, 3 is true in both views. D4 is true in this view down below. So 4D is true. C3 is not true in either view because it's not perpendicular or a dot. A way of thinking about it is the point 3 is closer to the viewer than point C is. And so because of that, we can't take the measurements, we have to take the hypotenuse of these two values. I have already recorded my answers for this whole video, so I'll quickly just talk about the other ones. So 2B is not a true length in either view. 3C is not a true length. 4D is a true length in this view. We said that 2, 3 is a true length in both views. CD is a dot, so it's a true length here. 3, 4 is a true length because it's a dot in this view. Okay, so what I said is, I've already done this video. When I was talking about this video, I talk about how if we know that D4 is in fact this true length, right? So from D to 4 is a true length. C3, it just makes sense that it has to be bigger because it's a diagonal here. It has to be bigger. So it is bigger than, C3 is bigger than the bigger of these two values. So we have this view and this view of C3. C3 here and C3 here. The true length of C3 has to be bigger than both of them because it's a hypotenuse, right? And a hypotenuse has to be bigger. Okay, so now that we're going to find the things that are not true lengths. So we're going to find, we'll start off by finding 2B, 3C. There are two that we need to find to start off with. So in a terminology I'm using more and more, we're going to call this plan and we're going to call this elevation. We don't usually use this term for these things, but I find it helpful. So the distance in plan is going to give us one side of our triangle, and our height in elevation, well, we've already drawn that by drawing these two parallel lines. So we're going from B to the 2 lines. So from B down here, which is on these, all the letters are on the bottom and all the numbers are on the top. So we're going from B to 2, and that is our true length 2B. The next thing we're going to do is we're going to go with C3. So we're going to go measure that out on the number line. So 3 is up here, and C is down the bottom on the letter line. So that is going to give us the true length of 3C. We're then going to have to triangulate this. We're going to need two more true lengths, but I'm not going to do those until we need them. Now, the thing that I actually thought was difficult when I was doing this is knowing which way to unfold this object. So it wasn't immediately apparent because they haven't given us a seam. I'm like, I'm not really sure how to, how this is all going to fit. So, this is also the way they showed in the HSE answer, which helps to compare what I've done to what the HSE has provided. Okay, so the first thing I've done is just a line, and we're going to mark out 1A. We said that 1A, because 1A is a dot in this view, 1A is a true length. So 1A, I didn't write that one out. 1A is a true length. So 1A is that length there. I can mark out A straight away. Now, sometimes when we have parallel lines like this, and we can see this is perpendicular, well, we can't actually see 1A in any view, but we can make a reasonable assumption. We can say this is perpendicular. I've said in the past, and this is how I've drawn this here. I've just said, well, these are perpendicular, and I've just taken the lengths out, and I've saved myself some triangulation. And then I've said these two should be parallel, and these two should be parallel. But you know what? I'm actually going to do this properly, and I'm going to show you how you would do it without, cheating. Because if you make a mistake at the start, the whole thing is going to look wonky. So we're going to find point 2 up top. So we know that 1, 2 is a dot, so 1, 2 is a true length. I've marked that already. And so 2 is going to be somewhere out here. 1, 2. And then we're going to go to
A2.
A2. Okay, it means we have to find that as a true length. Okay. A2. I didn't do this last time because I just did it perpendicular. Okay, so 2A. All right, so we're going from the 2 line down to A, just checking that looks right. Draw the line just to remind ourselves that there is actually a line there. Now, in the exam, you have 6 minutes to do that. I don't think that I'll get this done. This is a very hard question, I think, for 6 marks. The other one I just showed earlier, I think is actually easier for the marks that they are awarded. So there's our 2A line, and where those two things meet is 2. Now, I said that it would be perpendicular, and it turns out it is. Just for the sake of making this short, I will say that for the other line, I will actually just write out perpendicular. So that way I'm splitting the difference. Okay, so we've got 1B. 1B is down here. And I can just mark that out. And I have a tendency to firm these out as I'm going. I have the benefit of I can see a solution that I've already done, but it can be a bit risky that if you make a mistake, then those marks won't really go away very easily. Okay, so the next thing we're going to do is we're going to find, we found 2 and B, we're now going to find C. So to find C, we know that BC is a true length. So we're just saying somewhere here, so that was the wrong line, thank you. Yeah, no, I did get that, but I appreciate you helping me out before I make a big mistake. I would have caught that because I was about to write down BC here, and by writing it down, I'm less likely to make mistakes because I remember, okay, well, I've just taken BC, and by writing down BC, I'm like, wait a second, I didn't measure from B. But thank you, I appreciate that. Okay, so now what we're going to do is we're going to find C, but we're going to find C measured from 2. So we're going to take this distance here in plan, and that distance here in plan, 2C, okay. So measuring from 2 to 2C. So if we have the line 2C and line 2B, our value of C should be where those two meet. Now what I've said here is I've said, well, I can take that parallel and just draw my parallel line like that. But I will show you how to do it properly, right? And even if it's just a guideline saying, well, these should be close to being parallel, we can see that here they look like they're going to be parallel. Okay, so we got 2, 3, measuring from 2 and 3, 2, 3 will be out here. I said in my other video that keep in mind there's a lot of compound errors that happen here. 2, 3 is a true length. We're then going to go from C to 3, which we've already measured out. Could work past loop. C to 3. So I'll write in 3C. So don't be too worried if your values are out a little bit and it gets a bit wonky, because the markers will take into account the exam conditions. This is where showing you're working out is really critical. CD. Wait. Again, I measured the wrong thing. Okay. I'm used to the letters being at the top. I think this is where I'm getting confused, because I normally number the letters at the top. But anyway, so we just said that was CD. CD. And then we need to find 3D. So 3D is this line. The advantage of labeling things is if you make a mistake and you have to rub things out, you've got those values and you know what you're doing. That was 3D and D. Okay, then we're going to do, we said 3, 4 is a true length. Okay, so I'm going to be really careful to make sure that I go from 3 when I'm writing 3, 4. And then we're going to go 4D, which we said is a true length in that view. For D. And we're done. Now, like I said, could be a little bit wonky. We have an idea that these should be parallel, these should be parallel, this should be perpendicular, and as a matter of fact, these probably should be perpendicular too. Based on when I look at the seam, there's no reason why that. So that could save you some time. If you were rushing, you could say, well, if you can use your logic to say what would be perpendicular and what would be parallel, it could save you some time in the HSC. I'll just quickly, and I said this in my other video for this question when I did the whole exam, is we said before that, let's say the example of 3D, right? So here we have 3D in this view, and here we have 3D in this view, which we can see is a little bit bigger. The true length, which is the hypotenuse, must be bigger than both, which we can see is bigger than both. So if you don't know how to figure out your true lengths, so that you can do something, I would suggest you say, well, okay, which of the two of these values is bigger? This one's bigger. The hypotenuse has to be bigger still, and I would just expand my compasses. It's not a great answer. I mean, I'd much rather you do it properly, but if you have to use these options to try and put down something on paper, then better to do something on paper. Thanks.